All right. So this video is going to be completely dedicated to implementing handle stackable items. The reason I've kind of saved it until now is that it was originally I did not have this functionality at all. And I thought to myself, hey, I don't want to, this inventory is too basic. It needs to be able to handle stacks of things and handle them smartly. And so I had to do a lot of experimentation, a lot of debugging to get this working the way I wanted it. And so it, in hindsight, it was pretty complicated, but since I've already hopefully ironed out all the little weirdness with it, it will be a lot smoother this time, and smoother for you. So we've already gotten, handle add item is already done. We've already seen that handle stackable items as actually being called and working. It's just not doing anything in it, the contents of it. So it was returning a 0, but then this logic was checking that and giving the, reporting right here, could not add to the inventory, invalid or something like that. So now we're going to go ahead up here and we're going to start filling this out. So the way that I chose to do this was I thought to myself, okay, let's say we have 3 partial stacks of an item and we pick up another 2 or 3 of that. It needs to be able to iterate through and complete as many stacks as it can. So if you have, say we have a max stack of 4 and you have 2 existing stacks of 3 each, you pick up and then there's a 3 stack on the ground. What you want to happen is that now your 2 existing stacks become 4 and 4, and then the one on the ground, since you only added, you only added 2 to your inventory, the pickup would still be on the ground with a remainder of 1 in its stack. So that's the kind of logic that I implemented. And the way I did that was I said, okay, there's got to be a loop. There definitely has to be some form of a loop. And it needs to be able to look forward and look for existing partial stacks and distribute the item as needed. So to get started, the very first thing we want is we want to do some similar checks to handle non-stackable. Where we had to check for if the weight and everything is valid. So first we want to check if requested add amount is somehow an invalid number, or if is nearly 0 on the item in, what did I call? Oh, it doesn't have a name. Item in, let me make sure that the header, okay. So item in, if item in get item stack weight is somehow nearly 0, then obviously we just say, this is some invalid item data, so we're going to return. Return 0. All right, so assuming we pass that, what we're going to do is we're going to create a new variable, and it's called amount to distribute. And it is just equal to requested add amount. And again, this is so, I've done this in other functions. This is so that we're not trying to do math on a requested add amount that will get confusing when you're trying to debug. This makes it extremely clear what this is for. This is the amount that we have left to distribute to the inventory. We're then going to get an item reference and call this existing item. And it gets, to find it, we use find next partial stack, which we implemented when we first wrote the inventory component. We pass in item in. So all it's going to do is look for the next partial stack that matches that item type, because find next partial stack is the one that uses the lambda and just makes sure that that type matches based on ID. So it's not doing pointer comparison, it's doing ID comparison to say, is this the same kind of item? So we assume this gets an existing item to begin with. So what we want to start off doing is start a while loop that checks if existing item is null. Because remember, if find next partial stack does not find something that matches these conditions, it returns null. In this case, we want that to happen. We want to be able to say, you know, trigger this to run or not if this, based on if this is null. So this body of the while loop is going to handle iterating over existing items and distributing the amount. Now underneath the while loop, there will be another condition that is if inventory contents.num plus 1 is less than or equal to slots capacity. What happens? So what's going to happen here is distribute item stack over existing stacks, and what's going to happen down here is no more partial stacks found. Check if a new stack can be added. Right, because this way anything that when it finds the existing stacks, it'll put it into those. If it doesn't, it's gonna there may be some amount, so it might run both, because it might find two stacks, you know, like the little example I wrote to start. It might find a few stacks, distribute some of the item to those, and then realize, hey, there's no more partial stacks, so whatever's left, we add it as a new stack. So that's why we have the two sections here. So first we're going to need to calculate a few more things. So we're going to need to do a variable called amount to make full stack, and that's going to use the function that we wrote called calculate number for full stack, and we're passing in the existing item and the amount to distribute. We're then going to take so that's going to be, it finds a partial stack. It's going to say, okay, you know, this stack is a max of 4, but you only have 2 in it, so this would come back as a 2. We're then going to get another number that is weight limit add amount. And this one we're calling calculate weight add amount. We're passing in the existing item again, but this time we're passing in amount to make full stack. Right, because we may find that, you know, okay, there's a partial stack here and you can add 2 to it, but what if we're already so close to weight capacity that you can't add 2? So you need to do both of these calculations, because the final number that comes out will be how many you need to add to that stack, but it will be limited by the weight capacity. We always have to take into account the weight capacity. So now we say if our weight limit add amount is greater than 0. Now this assumes, okay, there must be at least a 1, right? There's weight room for it. So now we're going to take the existing item stack and we're going to set its quantity to whatever the existing quantity is plus the weight limit add amount. We're then going to adjust the inventory total weight. Get item single weight times weight limit add amount. And now, you know, with order of operations, multiplication happens first before addition in code. So you should be good to leave this, but you can also wrap it in parentheses if that kind of, you know, soothes your nerves a little bit, as it does for me. Okay, so now we've adjusted the existing item quantity and we've adjusted our weight, right? But we now, since this amount was distributed, don't forget that we have to account for that in amount to distribute. So now we subtract weight limit add amount off of it. We then take our item, our incoming item, right, which we assume is like a pickup or something on the ground, we now have to adjust its quantity by whatever, however many are left. So in this case, we've assumed like if we had 4 coming in and we were able to add 3, that means there's only 1 left, right, on the item on the ground or whatever. So that's why we set this directly to that. Now this might, it may happen again when it goes around, because it could find another stack, but that's fine. That's exactly how it's supposed to happen. So now the only last thing to do in this if statement is we want to check the inventory total weight and say, is it greater than or equal to our capacity? And if it is, that means, there's no need to go ahead and keep running the loop, because obviously now we're close to weight capacity. Or I'm going to put it to do here, because this kind of implies in a logical situation, because with all the other guards we've put in, you should not be able to ever have this as a, it'd be one thing if it was equal, but greater than or equal should never be greater than. So I want to, refine this logic, since going over weight capacity should not ever be possible. It may be as simple as just setting it to do an equals there, but it's something I want to think through a little bit. So I'm actually going to leave that note there for myself. And you can too. And if I figure something better out, I may come back and address that. But, basically this should be impossible. So it doesn't hurt anything, but it's just how how my brain works. I want all of my checks to be logical and be useful. So in any case, if you get here, if you do get to this situation, what we would do is we would call broadcast. And now remember, the amount coming out of this is used down here. And so we would say, okay, assuming that we called this happens, that means that not everything was distributed. So the amount coming back would now be some number here, and it would say partial amount added, and then it would tell us how many were actually added, right? But coming back to the pickup, under partial amount added, we're going to then update our interactable data. Now remember, we handle the actual setting of the item quantity and stuff right here in these functions. So what's going to happen in this case is we assume we were going to distribute. So say we had 4, but we only could add 3 here, right? So now this becomes a 1. Because if there was 4 on the ground, that means now there's 1 remaining. So now this is a 1. Then the reason why you do this is what I'm getting at, is explaining this. The reason why you do this is because this shows you the amount you actually added. Because if requested was 4 and now amount to distribute now becomes there's a 1 remaining, that means we must have added 3. So we return a 3. And what you'd get here is, partial amount of item added, number added 3, because there's actually, 4 on the ground. Okay, so we've got that first if statement. So now what is next? So now we want to say, well, else if weight limit add amount is less than or equal to 0. This just means, obviously, we've gotten around back to this and these came back, it's really close to weight capacity now. So you need to do a check to say if amount to distribute is not equal to requested, then that obviously means there was still some left. We go ahead and call broadcast and return the same thing right here, because basically it's very similar. Rather than this happening, during the process of adding, it happened when we came back around and tried to add some more to another partial stack. And if amount to distribute is equal to requested add amount, you would return a 0 here. And the reason for that being, right, this would mean these are equal and they've subtracted out and then there's nothing left. So there's no, there's no amount still. So like if requested was a 4, like on that example I talked about earlier, now amount to distribute has been reduced as this runs. So if requested was a 4, but we actually distributed 4, you would return a 0 here. Well, this is the same kind of thing. This is basically saying, they are equal, even though, we can't add anymore, but we were able to distribute everything. So then that's why you return a 0. Now, if all of this gets skipped, the very last thing you want to do is if amount to distribute is less than or equal to 0, that means that we didn't have to go through and do anything with the partial stacks, right? Because this is all these calculations up here looking for actual partial stacks. So if all this stuff didn't happen, then that just means, well, we must have distributed everything. So again, call broadcast to update the inventory, and then return. We added every bit of it. All right. So these situations up here assume that there's only a partial amount was added. This one assumes, okay, you distributed everything. So now the very last thing, I kept saying that, but this is really the last thing. So remember, we're still in the while loop. So now what we want to do though is we want to say existing item is equal to find next partial stack of item n. This way, it will continue to look forward through the inventory for each existing item stack. And that's probably something I should do, is rename this, because I guess, did I use it down here? No. All the partial stack calculations are happening up here. So as you can see, existing item is only used up here, and then obviously this one to keep looping. A better name for this to make it even more clear is going to be something like existing item stack. So I'm going to refactor this and rename it and change that. So existing item stack. Now, it makes more sense with the function because it's going to find a partial stack. So then you would get an item stack, do your calculations on that. Okay, so now we're down into the bottom part. This is saying no more partial stacks were found. So we're going to look and see if now we still have room to just keep adding it to the inventory as a new stack. So I'm sure you can guess the first thing we're going to do, assuming we have capacity space, is we're going to calculate weight limit add amount again. And this one is going to be, rather than a existing item stack, right? Because this is no more partial stacks are found. We're going to call calculate weight add amount, but we're going to use item in and amount to distribute. Because at this point, this could, like I said, when I started, these could happen together. You could get through all your existing stacks, but still have some amount to distribute. So that's why we're going to calculate that in this way. Again, if weight limit add amount is greater than 0, we also need to say, hey, is it less than amount to distribute? Which we did earlier, the similar thing. Because this is basically saying, there was still 3 we needed to give out, but then we just calculated that now it's only 2. If that's the case, we go ahead and start adding it. So amount to distribute minus weight limit add amount. We set the quantity. we then call add new item. And what we're going to do is now create that copy that I talked about when we were designing the inventory component. Because remember, if we don't do this, if we call add new item on item in, what would happen is basically this is only going to happen, right? This is only going to happen if you can't distribute everything. So there's still going to be some, like say it's a pickup on the ground. There's still going to be some on the ground. If I add new item and just call item in, I now have a place in memory that refers to that pickup on the ground and an item in my inventory at the same time. And that's bad. That's bad juju. That's going to make it to where you get some serious bugs, which I encountered when I was creating this, where, you know, you start trying to do stuff on the inventory and like the numbers get all crazy and it just went very badly. That's why I came up with the create item copy function and realized that was crucial, right? Because if we're adding a new stack, we're still going to reduce everything on the pickup on the ground, but now this new stack gets treated as its own item, so that it has its own place in memory, essentially is what we want to do that for. And then again, since they were different, we just take this same calculation and that's what we're returning. Now, if this was false, then that would assume that the full remainder of the stack can be added. So now you actually do that, because remember, this is still okay here because this is saying there's some still remaining elsewhere. This would only happen if there's not. So that's okay in this case to call add new item on item in, because you've picked up the whole thing. You don't have any else laying around that's going to point to that same place in memory. And then we return our entire requested add amount. Now the last piece, we're actually done now. We're gonna add a couple of informational comments here to help clarify all this. But the last piece would be, you know, if somehow you get all the way through, you just return your requested add amount minus your amount to distribute, and then you're done. So let's add some comments here, because you know, I know this was kind of fast. I did try to explain all the logic behind it, but comments are crucial even for your own code. That's actually one of the best things to put comments for, is because say you know, I go in cycles with Unreal Engine coding. It's kind of like a hobby for me, but not one that I've been very disciplined with and stick with and actually make finished products. So there will be times where I, you know, stop for like 6 months and then I come back, and, you know, if I didn't have anything, I'd have to slowly digest this again and figure out, like, why did I do that? Why was I putting that there? So I put lots of comments in just to help myself. Okay. And so you should do that too with these, you know, with these kind of little projects that you might not be, you know, spending time on all the time. Also on projects that are massive, where there might be a section of code that, you know, once it's verified to be working, you know, you don't really need to come back to it that often. But when you do, those comments are there. So for our existing item stack, we're saying, you know, check if the item already exists in the inventory and is not a full stack. Amount to make full stack is just, you know, calculate how many of the existing item would be needed to make the next full stack. That one's pretty self-explanatory. Weight limit add amount, calculate how many of the amount to make full stack can actually be carried based on weight capacity. So then we would say, okay, we've done those calculations. As long as the remaining amount of the item does not overflow weight capacity. Adjust the existing items stack quantity and inventory total weight. Adjust the count to be distributed. And then this one, this is pretty self-explanatory. We're now setting the whatever partial amount is left to that item. And then, I already kind of addressed this one. So this one's, still put a comment there. If max weight capacity is reached, no need to run the loop again. So you just return. All right. So now we get down. So say we get down here, and this one would basically say, all right, our weight limit add amount is less than or equal to 0, but there is still some to distribute. This block will be reached if distributing an item across multiple stacks and the weight limit is hit during that process. Right, because basically you find an existing item, you find another stack, then we're still in the while loop, but this is 0, right? So we reached here, and it's basically saying, okay, we're still in the loop, so there is still an existing item stack, but we can't put it all in the inventory. So basically the weight limit is hit during the process of the loop. Okay, and now this one would say all of the input item was distributed across existing stacks. There's no more left to distribute, so we don't need to keep looking forward. We just return, update the inventory. This is the check at the end of the loop to say, check if there is still another valid partial stack of that item. And now back down here, this is the one that's basically saying, okay, all partial stacks have been filled. Find next partial stack, return null. So the while loop exited. So then we need to go here and no more partial stacks are found, right? So check if a whole new stack can be added. So we've already got that comment. Attempt to add as many from the remaining item quantity it can fit inventory weight capacity. So say we do have some that we can still add. If there is still more item to distribute, but weight limit has been reached, adjust the input item and add a new stack with as many as can be held, right? So this is saying like you are adding a new stack, but that entire new stack can't fit. We're just going to add as many as we can. Create a copy since only a partial stack is being added. And again, I already explained this, but you don't want to have this memory reference being both the pickup on the ground and the thing you're just adding to your inventory. Otherwise, the full remainder of the stack can be added. Okay, so I did this in what, 20, maybe 30 minutes, and this was probably a month when I first decided to create this, of tinkering and debugging and troubleshooting and scanning logs and trying to figure out frustrating memory situations. So, like I said, I hope that, you know, it went a lot smoother this time. We're gonna launch here in a minute and debug it. Or I mean not debug, but debug it if we need to, but hopefully we won't need to. So let me just look really quick. I think we've got everything. It's all filled out. All the functionality should be there. I think it's time to go ahead and launch the editor. And since we have that that potion that's a stackable item, we can start testing this out with that. All right, we're back in the editor, and we don't need to do anything else. We can go ahead and test this out. So these errors right here, I did go and I added a log in the item base that I didn't really think it through. I was like, oh, you know, I do want to know if this is null. And so that happened because there's 4 pickups in the world, and pickups don't have an owning inventory. So when that creation process was running, you know, it went through here, it was setting their quantity, but there was no owning inventory for it to do this check on, and so that's why we got that printout. It's still useful, but it should probably say something like owning inventory was null. Ignore if item was a pickup. So just wanted to address that in case you noticed that there and got curious. But all right, so let's stop wasting time. I'm going to pick up my regeneration potion. And now, check this out. We actually have our quantity. Max stack size is 5. Quantity is 3. It's a consumable. And it heals 30 HP. So all my little description and stuff is looking good. Weight is 6, and I think that's because they weigh 2 each. Let me just double check that. Yep, so their weight is 2, max stack size of 5. Everything else looks good. Oops. Drink is not capitalized. Yeah, see, it's like, I would need to rearrange that a little bit, because that, see how it says drink right there under consumable? That's like kind of random. I think that should be something like maybe at the very bottom, and it would say more of like used to drink or something, or used to consume. Maybe consume is going to be better. So just again, another thing to tweak on the tooltip, just to make sure that it always looks good and makes sense. All right, so now what we expect to see is when we pick up this other potion, we're still not over the max stack size yet, so this should be a 4. Okay, so that's good. And now weight is 8, so the math looks good. Capacity and weight down here are good, 8 and 1. What we need to do is get back out of this and edit this to where we can force one of those partial stack situations. So we can leave this one at 3, but now this one, let's make this one also be a 3, because then what will happen is, or let's do a 4. What will happen is, since the max stack size is 5, you'll get 2 added to that stack, and what we should see is another stack of 2 then gets added to the inventory. So let's test this. All right, there's my 3, and there we go. Weight of 10, that matches for the stack, 5. And then a weight of 4, still tells us it's a max stack size of 5, but we have a 2. So we have 7 times 2 becomes 10 and 4. Weight down here, 14. 2 capacity. So that's it. That's what I wanted with the, you know, when I originally had this thought creating this and it didn't handle stackable items, I said, you know, I want this to automatically be smart enough to distribute this and do all the calculations, you know, as you would expect. Now there's one more little check we can do. Let's add another one. And let's make this one I'm hitting buttons on accident. Let's make this one let's actually do 3 of them at 4 and make one more but have it be a 5. So you should end up with 3 full stacks and another stack of 2 on the side of that that's added brand new. Okay, so let's pick up these 3. So regeneration potion times 4. Oh yeah, no, I messed up. It's gonna calculate it. I wanted to have 3 stacks of 4 sitting in the inventory. We will be able to do that. We will be able to do that check, but we can't yet because we don't have the split functionality. If we had the split, we could customize it here to be however much, but right now we can't. We're just gonna, you know, it's just gonna keep adding to the stacks, but it's still fine. We can still do this. So now at least, you know, 3 full stacks, and then this one will be, there will still be 2 remaining, which is basically what I wanted. I just wanted to show that it would distribute it across all 3 before it added that. So there we go. 3 stacks of 10 makes a weight of 30, plus 2 is 4. Weight looks good. We have 4 slots. That's a capacity of 4. So I think we can call this good. I think that handle stackable is now working. And we can also, oh, you know, before I stop, go pick up some of the other stuff too, so we can pick up buckets as well. All right, because, you know, we have all the logic implemented at this point. So we saw that it was 34 with all the potions, and then buckets are 4 each. So 34 plus 8 is 42, and we have 6 slots. So everything's looking really good. You can take these, you know, you can drop the potions too. Everything's working as far as our drop. And if you go back and, you know, pick them back up, one thing you'll notice is because it's an array, it's going to add in order. So if I now pick up a bucket and then pick up a potion, now what we should see is full stack and then 2 remaining again. And that's, you know, because of our while loop that goes through and it says, okay, yes, this is 1, but it's the full stack. Here's a partial stack, add. This item ID does not match, skip. And then so then there was no more partial stacks at that point, so it added the remaining amount to distribute here as a new stack. Full stack and then a 2 looks good, and then we can go pick up our bucket. And if you notice, everything is still tracking. 6 capacity, weight is back to 42 where it should be. Those are the things you need to, you know, watch that very carefully, because this is right where it can go wrong. As I mentioned, when I was first catching those bugs with the memory reference stuff, at some point my weight like came up negative, and then there was like a case where like I would pick something up and it would keep adding like a weird amount, and then the weight was off. It just got crazy, and so that's why we need to be able to create item copies, is to avoid duplicating memory references. All right, so let's see, before I end, there are a few things that I should have probably mentioned at the beginning, but I forgot. In the last video, I talked about how I did not want to be able to drag and drop an item onto my inventory panel. So if you'll notice, that is now resolved. And it was very simple. The way it happens is, or the way to fix that is, if you come back in here, come back to your code, go to your inventory panel CPP. What I did was, you don't need to fill this out exactly the same way I did, but you can. I mean, this is what we're going to be able to drag stuff into the inventory at some point anyway. So very similar to what we did in main menu.cpp. If you go under user interface, inventory, user interface main menu.cpp. Remember, we took the incoming operation and casted that to our item drag drop. Do the exact same thing here on this line. And then I said, okay, if I have a valid source item and my inventory panel has a valid inventory reference, all I'm doing right now is printing a log saying, hey, detected an item drop. And then I return true. And see, notice I put comments here for myself. If you return true, the drop operation stops at this widget. Otherwise, returning false will cause that operation to fall through. And if there's any widgets underneath of it, it will try to do the drop operation on those. So I tried to fix it briefly at the end of the last video, and I think I just did return false. But the return true is really what causes it to stop, right? And so in this case, we now have a valid, a drag drop operation in progress in memory. So now these widgets are going to be waiting to see, does it detect a drop? And in this case, we detect the drop, and you will see that there is a log here, detected drop on inventory panel, but nothing else happens, right? It doesn't fall through. There it is again. It doesn't fall through and actually do the drop item on the main menu, which is all the other space on the screen. That only happens if you actually drop it on that part. I did also, and if you go to inventory item slot.cpp, I did put in a tiny little check here for, I mentioned this last time. Notice when we pick up the potion, let me zoom in again. You pick up the potion, you have the 5 on the little drag visual, but the bucket doesn't have it. And when you pick it up, it also doesn't have it. So that's what was there before. The bucket would show a 1. And so all I did was I did a ternary operator check to say, hey, when you're creating your drag visual, if it is stackable, then we want to show the quantity. Otherwise, we say item quantity, set its visibility to collapsed. And so that way you don't get that 1. And it just, to me, it's just a little cleaner that way. Everything's consistent. The only other tiny thing I did, which you may have noticed, is that I commented out the line trace. We're at the point now, that was really just kind of a confirmation that everything was working and that our interaction system was working. We don't really need that, and we're going to expand on our player character to be able to do the zoom in and aim I've been mentioning. And so we may enable it again for that just to make sure that things are good, but you don't really need to keep this on the entire time. So those are the only tweaks that I did. Everything's looking real good and seems to be working really well. We've got stackable item functionality now. And so at this point, if you can take this and expand on it pretty easily to add any kind of other custom stuff you want. So yeah, in the next video, I think will be the one where I add in this aim functionality, and then I'll start working on showing how to build containers, like chests and stuff that you can interact with.